Hello and welcome. In this video we are going to build a simple yet effective trading strategy with Python. Strategy we are going to cover is cross-sectional momentum, very popular across academics but also in institutional research. So what is cross-sectional momentum? You rank a group of stocks based on their past performance. Then you buy the winners, or you sell the losers, or you even do both. In this video I'm focusing on buying the winners. And then you rebalance, usually monthly. Now how does that work in practice? You pick a universe, so for instance the S&P 500, which we are also doing in this video. Then you define a look-back period. The most common one is last year, so past 12 months, and you take a look at the returns and you exclude the last month. Reason behind that is short-term reversal. And then you rank all stocks by return and you go long the top X%. So for instance, you want to check the top 10, top 20, top 30, or whatever you want to check. And then you hold this for exactly 1 month. So let's code that all in Python. First of all, libraries. yfinance to pull stock prices from the internet and pandas for data handling. Next, I'm going to read in a CSV file containing the S&P 500 historical components and also changes. I got this data from a GitHub repo, which I will link in the video description, so all credits to the repo owner. Please check the video description for reference. So I'm going to store that in CDF for composition data frame and use pandas read CSV file and paste the file name here. And I'm also setting the index column to the first column, ending up with a composition data frame like this. So I got a date as an index and the composition of the S&P 500 on that date. So why do I need that? Short answer is survivorship bias. And to elaborate a bit on that, so imagine you would just take the S&P 500 composition as of today. Then you simply would include stocks in previous dates if you do a backtest, so an analysis back in time, and include stocks which are today in the S&P 500 but were not back then. And then you have a whole bias in your data set or in your data set analysis because you are including stocks which would have not been in the S&P 500 back then. And let me tell you one thing, the results will be way better, which is obvious because you're just including skyrocketing stocks which are going up in the S&P 500 in your analysis because you just include those stocks even though they were not part back then. That being said, let's do some manipulations to this data frame so we can actually use that. So the index of that data frame is currently object data. So we're just going to transform that to datetime objects so we can do some comparison based on data timestamps on that. So I'm just going to set the index to a datetime index here. So you're getting a datetime index for this data frame. And next, I'm setting up a function to get the tickers for a given date. So I want to pass a date to that function. So for instance, September 2024 or October 2024. And then I want to get the composition of the S&P 500. Background here is simply when I'm going to create this strategy later on, I'm just checking, hey, what is my current portfolio as per that date to avoid survivorship bias. So let's set up this function and the logic is pretty simple. As long as your date is not after this date, you're just taking the latest S&P 500 in this composition data frame. So how do you set that up? You just create a function here, so get tickers for a given date, and then you take the CDF and date here, and then you simply do what I just said. So if the date is larger or equal to the last index, then you simply define your tickers as the last row's tickers here, right? So you just take this row here for every date, including this and after this date here. So last row here, and then you screen for the tickers. Else, so if you get a date before that, then it's pretty tricky, because the dates in the stocks we're going to pull in some seconds might not align with those dates here, right? So these are dates which have a random frequency here. Sometimes they're daily, sometimes weekly, sometimes monthly. So you just pick the first available date after the past date here. And how can you do that? Simply, you just define ticks, screen for the past date, and you screen from that date on. So let's say you pass the 1st of October, then you screen from that date on, this data frame from that date on. So you do that with a colon here. And then you simply screen for the first available row here with ilog1 and take the tickers. And then as you're just getting this string containing the symbols, so I can actually show that to you. If you just screen for the last available row here, you're just getting a string of those tickers here, comma separated. You can just split that using a comma, and then you end up with an actual list, which you can easily use then. So you see, you want to have something like this here. So in the end, you just return ticks split comma to get a list of tickers. So once again, to summarize, what is this doing? This is just taking a given date and then screens for the composition of the S&P 500 for that date. So it just takes the date and then screens the rest of the data frame from here, and then simply takes the first available date. So you just align the dates here, and if it's in the last row here, you're just taking the last row. Nothing more than that. So next, more interesting part now, pulling the actual price data. All right, and I'm just taking the S&P 500 tickers here, the last available ones. So we could just use this one here. Not this one, of course, but this one. And take the list here, store that somewhere, SP tickers. You could obviously also just call this function for a given date. You would also get the same results here, would have been the better way. But it is for how it is now. So we are just starting some random date in the past. So I'm starting my analysis beginning of 2010. You can start whenever you are interested. So just pulling the close price here for all the S&P 500 tickers for the most recent time. So this is going to take a couple of seconds, but you will end up with the data frame containing all close prices for all 500 something S&P 500 stocks here. So this is looking like this, getting some failed stocks here, but shouldn't be an issue for now. So this is looking like this. We have the tickers here. So for instance, a very popular stock here, Apple, and then prices from 2010 until the last available trading date here. So simple metrics using an index here and the stock prices as columns. Now, let's design the momentum trading strategy. First of all, monthly prices. So why monthly prices? Because we want to calculate the 12-month return, as this is our look back period. So we are just going to pull monthly prices, so the last available price for a month, and this is our base to calculate the 12-month return. So let's do that. Let's define monthly prices here. Use df, resample that on a monthly base, and pull the last available price for a given month. So you would end up with a resampled data frame. So how do you read that? Apple end of January 2010 is $5.78 US. Good times. Imagine you would have bought there. So last available price. This is end of month March here. So Monday this will change because now we are on Sunday and there's one more price point flowing into that. But this is just taking the last available date here. So 217 for end of March. Got the monthly prices. Now we want to get the momentum. So the momentum is super straightforward. You just take the monthly prices, apply the PCT change function, so the percentage change, and then you define a rolling window or a window of how many rows you want to include in that percentage change. And with that, you're just including the last 12 rows from a given row on. So you just calculate the percentage change over the last 12 months in our case. And now, very important, we said that we want to exclude the last month. So you want to exclude the month you are currently in. Meaning, when you are here in February 2025, you want to have the last 12 months, but you don't want to have the February. So how can you do that? You just calculate the last 12 months, but you shift then the calculated last 12 month percentage change and shift that by 1 month. And with that, you just skip the most recent month, in that case, February. So you shift 1 month to exclude the last available month and got your momentum series here. So we have momentum, and obviously the first 12 rows will be containing NaN values because you don't have any previous month here. And then you end up with this value. So how do you read that value? For whatever stock that is, you are getting a return of 26-ish% over the last 12 months from the perspective of November 2024, excluding the November month. All right, so this is how you read that. And then you just set up a portfolio data frame where you store your monthly portfolio because you're doing monthly rebalancing. So I'm just setting up a data frame here. Define my index as my monthly prices index because these are my monthly dates, and my columns are just my monthly prices columns, so my stocks. And this data frame obviously will just look very similar to what you just saw, the DF, but for now it's just including NaN values because we don't have anything in there yet. But we'll fill that. And how will this work? You just screen now for the momentum, and then you will have picked stocks. So the top, let's say 20 performers, and then you have data filled in here for a given date for those stocks which are included in the momentum portfolio. So let's do that. And that for that you just use for date in momentum index and skip the first 12 rows because, as you know, includes NaN values anyways because you don't have this data. And then you define a portfolio for a given date. You just use momentum and then log for that date. So you have a portfolio for a given date or just a row for that date. I will play that through for a given date in some seconds, but let's go through the loop logic first. So you have the portfolio for a given date, and now you need the relevant tickers. So just imagine you have one row here, take this row, and now you need the relevant tickers. And the check now is simple. Does this stock exist back then? And you can just check now using the getTickerState function here. So how do you do that? You simply just screen for the relevant tickers. So relevant tickers are getTickerSdate for the composition data frame and a given date. So in this case, the date we are looping, and then you define your portfolio for the given date filtered for those relevant tickers. So you simply take portfolio date where the portfolio date index is in those relevant tickers. So super simple, you just include only the tickers which are part of the S&P 500 back then. And then you define your top 20 by simply taking the portfolio for a given date and screen for the largest 20 values and pull the index, so you're getting the names of the stocks here. And then you just simply take the portfolio data frame I just showed you. So the data frame looking like this, full of NaN values, no data in yet. And then you just write back there and you log for the date and the top 20. And you also have to assign now the weight you're passing. So in this case, you check for the top 20. So every component in the portfolio has a weight of 1/20. All right. So if you have top 10, you have 1/10 and so on, assuming equal weight of the assets. So that's an important assumption here. Now, this messed up here somewhere, just a typo. So getTickerState, sorry for that. Top 20 is not defined because I'm just too stupid to write here. So after 3 tries here, you have your portfolio, and your portfolio at first look still looks full of NaN values. All right, but now let's check for a certain date. So if you have the last date through your loop and check for that date, and then check for the last available top 20, which would be these values, then it looks way more meaningful, because then, and this is pretty nice to see now, it's just showing you the momentum portfolio. So you see, these are the stocks you would have picked based on the past 12-month performance for the March date. So this is your portfolio, and what you're seeing here, by the way, are just the weights. So for every given date, you have a momentum portfolio consisting of certain stocks for every month. And the idea is now very simple. You calculate returns for the monthly prices, and then you just take the weights and multiply that with the returns and sum it all up. All right. So you define returns as, then you take the monthly prices again, apply percentage change to get the percentage change over that month. And then you just want to have the next month return, because remember we said we hold the portfolio for 1 month. So you have to shift 1 month back here to get the next month return here. So with that, you're getting the returns. So you have all returns, and now you simply multiply the portfolio with the returns and sum it all up in the end. So you can just do that with sum on axis 1, and this is your strategy return. So let's define that as strategy returns. And if you plot that now, so to accumulate returns, you have to add a 1 and take the cumulative product. Explained that in detail in another video. So let me know if you need more information or more explanation or more clarity on that. So you just add 1, take the cumulative product, and then you could plot and get cross-sectional strategy return here. And this is a very effective, as you saw, strategy. Now the big question is, did this outperform the S&P 500? So this basically tells you it would roughly 6x your capital since 2010. So quite an insane return. But remember, the S&P also was performing crazy since then. So let's quickly pull the S&P returns here. So just downloading data for the S&P index starting 2010, and then take the close, and then same story as before, right? You take the S&P data, apply the percentage change function, add a 1 to that, and then accumulate the products, so cumulative products plot, and then you get the S&P returns. So slight outperformance of the S&P 500, S&P 500 roughly 4x momentum, cross-sectional momentum, long only strategy roughly 5-ish x here. So super interesting one. Obviously no investment advice. Past data is not a guarantee for future returns, but definitely something you should have on your desk. So what can you do from here on? You can include the losers. So short the losers, short the top 20 losers, and see if this is boosting or making your strategy worse. And then finally, you could also do a so-called winner minus losers portfolio. So you take the winners and the losers and see the performance if you include both. I hope this was interesting for you. Let me know what you think below. Thanks a lot for watching, and I'm looking forward to seeing you in the upcoming videos. Cheers. Bye. Bye.